look at this question related to finding z values given probabilities of a standard normal random variable. So we want to know that given a certain probability of a normal random variable z, we want to find the associated z value for that. So before we dig into this question, there are two things that we need to keep in mind for this particular question. So there are two things that we do need to keep in mind while doing this. Number one, we need to keep in mind, the total area. The total area under the PDF of any continuous random variable. In this case, we're looking at standard normal random variable, but for any continuous random variable, we know total area under PDF must equal 1, right? Because we know area under PDF gives us probability, so total area under PDF must equal 1. Must equal 1, right? We know this. The total area under this PDF. So if I have the PDF for standard normal random variable z, so we know it's bell shaped like this, and it's centered and symmetric about its mean 0. So this total area is 1. Right? Now since z is centered and symmetric about its mean, right? Any normal random variable is centered and symmetric about its mean, and in the case of standard normal random variables, that mean is 0. Since z is centered and symmetric about its mean 0, so area on either side of 0 is 0.05. So this is important to keep in mind when you're finding z values given probabilities, right? One type of question is you're finding probabilities of a standard normal random variable. Here we're given probabilities, you want to find associated z values. Here it's very important to keep in mind total area under the PDF is 1, and since the standard normal random variable is centered and symmetric about its mean value 0, so area on either side of 0 is 0.5. So this area is also 0.5. Probability z is less than 0 is also 0.5, and probability z is greater than 0 is also 0.5. So this is very important to keep in mind, right? That because the total area under the PDF is 1, and since the PDF of a standard normal random variable is centered and symmetric about its mean 0, so area on either side of 0 is 0.05, right? So probability z is less than 0 is also 0.5, probability z is greater than 0 is also 0.5. That's the first thing to keep in mind. The second thing which we should keep in mind even when we're finding probabilities is that the z table that we have, a z table has CDF values. So this is important to keep in mind. It has CDF values, right? Which means values in this form. Probability z is less than equal to small z for positive values of z only. So there are two things to keep in mind that the z table we're working with, it has CDF values for positive values of z only. So this is important to keep in mind. So any question which does not fit this criterion, that you have CDF value for positive values of z only, we have to rewrite it in a form that we can read it off from the table. So these are two things that we need to keep in mind when doing this. And let's move on to question 1, part A. So part A says we're told we want to let the random variable z. The probability is 0.7 that z is less than what number? So we want to find the probability is 0.7 that z is less than what number. So we want to find what is this number a that z is less than such that the probability is 0.7. Now we want to find what this number is. So for this, the first thing that we're going to do is we're going to plot its roughly its PDF, right? So this is z, and we know it's centered in symmetry got 0. Now we need to figure out where would this a, right? Or where would this value of z lie over here? The first thing that we need to figure out is when you're doing such questions, we want to find z values given probabilities of a standard normal random variable. We need to figure out, will this value be a positive number or a negative number? That's the first thing we will try to figure out. So over here, we know this area is 0.5. We know this area is 0.5, right? So A cannot lie over here, because if A lies over here, then the probability that Z is less than A would be a number smaller than 0.5, because this entire is 0.5, right? This entire is 0.5, right? So we can't have A over here, right? A can't be a negative number, because the probability that Z is less than A would be a number less than 0.5, so that's not possible. So this means that A has to be a positive number, right? So the first thing whenever you're doing such questions is to figure out whether A is positive or negative. In this case, A is going to be a positive number. Why is A a positive number? Because the probability Z is less than A is 0.7. We know this entire part is 0.5, so this would be then, this can be 0.2, right? So it has to be positive, it has to be greater than 0. A has to be greater than 0 because the probability Z is less than 0 is 0.5. So probability Z less than A can only be a number greater than 0.5 if A is positive, right? Because this is 0.5 and then this would be the 0.2 over here. So the first thing to figure out is that A would be a positive number. So the first thing whenever we're doing such a question is to figure out whether it's a positive or negative number. A would be a positive value. Since the probability Z is less than A is greater than 0.5, right? So the probability that Z is less than A is a number greater than 0.5. And that's why it's important to keep in mind the area on either side of 0, 0.5. This is already 0.5 and you want probability Z to be less than A to be 0.7. Then we want A to be greater than 0, right? So this is essentially now, so this area is the probability Z is less than A, which is 0.7. So the first thing to keep in mind over here is to figure out whether A is a positive or a negative number. Now in this case, A would be a positive value. So now I can write probability Z is less than A as phi. You know, we use phi, this to represent the CDF of a standard normal random variable is 0.7. Now what we're going to do is we're going to find A as phi inverse 0.7, and this we're going to read from the Z table. Read from Z table. How are we going to read? So this is reading the Z table in inverse now, right? So let's open the Z table up. Sorry. Let's zoom it up. So the way we're gonna read it now, we want to see, okay, for what we want to look at the probability 0.7 and find the corresponding Z value. So we'll try to find which probability over here is closer to 0.7, right? So we can see, okay, we had these are closer to 0.7. We have this number, we have this probability, and this probability close to 0.7. Right, let's just highlight this. So we have two probabilities here close to 0.7. The closest to 0.7 is this and this. So now, if one of them is more closer, then you choose that value. Right, so one of them is more closer, then you choose that value. If they both are equidistant from 0.7, then you take the average of these, right? So let's see, is 0.6985 closer to 0.7 or 0.7019? In this case, 0.6985 is closer to 0.7, so we'll take the z value associated with this, which means the z value associated with this is 0.52, right? So we're gonna take this to be 0. So A is 0.52. So probability that Z is less than 0.52 is 0.7, right? So why did we choose, right? So whenever you're reading the Z table in inverse, given the probability of trying to find the Z value, you look up which two values are the closest to, you look up which two values are the closest to 0.7. If they both are over here 0.6985, we don't have exactly 0.7, right? If you exactly had that number, you could have just read the associated Z value with that. So here, so the first thing is you see, do you exactly have this probability in your Z table? If you have it, then just read the associated Z value. If you don't have it exactly, you find which two values does it lie between, right? So we'll see which two values does it lie between. So it lies between 0.6985 and 0.7019. And you'll choose, and if they both are equidistant to 0.7, you take the average of the Z values, right? If they were both are equidistant, then we're taking the average of 0.52 and 0.53. But if one is more closer, which in this case 0.6985 was, you would take its associated value. So the way you read the table in inverses, you see, okay, is this probability already present inside the Z table? If it is, just take its associated Z value. If it's not present, then you see which two values does it lie in between. If it's equidistant to both of them, you take the average of the Z values. If it's closer to 1, which in this case it was closer to 0.6985, you take its associated Z value. So now let's look at the next part. So we'll just clear all of it up. Let's just for a minute just make this smaller and then we can look at this later. So the next part is the probability, just a second. Okay, now we can look at this. Part B. Part B is the probability is 0.25 that Z is less than what number, right? So B is, what number is z less than such that it is 0.25? Right, so again, the first thing that you should do is you should first make the PDF and try to figure out whether a is going to be positive value, negative value. Right, we know this is 0 and this is. Now we know the probability that z is less than number is 0.25. It's a number less than 0.5. We know the probability z is less than 0 is 0.5. We know this because total area under PDF is 1 and z centered and symmetric about its mean. So area on either side is 0 is 0.5. So here, their probability z was less than a was 0.7, was a number greater than 0.5, so a was a positive number. Here, the probability that z is less than a is 0.25. I can't make a positive number now because this entire area would definitely be more than 0.5 because only we know for sure that this much is 0.5. And we're sure that this much is 0.5, so in this area would obviously be greater than 0.5. But we know the probability z is less than a is just a number smaller than 0.5. Right, so in this case, a has to be a negative number, right? So we know in this case, a will be a negative number. So if we have a as this, so this much would then be, this area is then the probability z is less than a, which is 0.25, right? So it's very important to figure out whether first a is positive or negative, and for that we'll keep in mind the area on either side is 0 is 0.5. So if we have probability z is less than a is a number greater than 0.5, so obviously a had to be here. But if we have probability z less than a to be a number smaller than 0.5, so a has to be here because we know all of this is 0.5, right? So if I make a anywhere over here, so it would obviously that area would be less than 0.5. A can't be positive by any means, right? Because we know this is already all of it is 0.5. So probability z less than a would definitely be greater than 0.5, and that's obviously greater than 0.25. So a has to be a negative number in this case. Right, so a would be a negative number, a negative value, as probability z less than a is less than 0.5. Right? So a has to be a negative number in this case. Now, why is this important? This is important. Like we said, whenever you're doing this, whenever you're given the probability and you want to find the associated z value, you need to first figure out whether this number is positive or negative. In the first case, it was positive, so I directly wrote it as phi a. Here, I can't write this as phi a. Why can't I write this as phi a? And there, though, we directly wrote it as phi a, and then we took the inverse, then we took phi inverse on both sides and found the value of a. Here we can't do that. Why? Because here a is a negative number. That's why we needed to figure out whether it's negative or positive number in this case. So use symmetry property. Why do we need to use symmetry property? Because like we said this is something we should keep in mind, that the z table only has CDF values for positive values of z. So over there, when we were doing probability z is less than a is 0.7, because a was a positive number, I could just write it as by a, because the z table has a CDF value for this, for positive values of z. But the z table does not have CDF values for negative values of z, right? So when we know over here a is a negative number, it's some negative value, right? Because it's a negative number, and we know the z table does not have CDF values for negative values of z, so we'll use first the symmetry property, right? Over there in part A, we were easily able to write probability z is less than a 0.7 as phi a is 0.7. The reason we could do this was because we were sure that a is a positive number. So then this CDF value phi a would be present inside the z table, right? Because phi represents the CDF of the standard normal random variable. But in this case, because a is a negative number, the z table will not have phi of a. Phi of a won't be in z table in this case because a is a negative value. Over here, see, they're all positive values of z. So we can't find a negative value of z over here. So whenever you find whether, because this is true even when you're finding probabilities, right? So whether you're finding probabilities or whether given probabilities you're trying to find the associated z value, if you figure out this value of a is a negative number, you have to use symmetry property, because the table that we're using does not have CDA values with negative values of z. So when I use symmetry property, so by symmetry property, probability z is less than a 0.25, this is going to be the same as probability z is greater than minus a, right? This is probability z is greater than minus a. Here, keep in mind a is less than 0, so minus a is greater than 0, right? So minus a is a positive value. So by symmetry property, probability z less than minus a is the same as probability z greater than minus a is 0.25. Now minus a is a positive value. But now we know the Z table only has CDF values for positive values. See, first we said, okay, this was a CDF value, but this was a negative value of Z. So we had to rewrite it using the symmetry property. Now, again, this is not a CDF value. We need to write it in the form probability Z is less than equal to some value, right? Because we know the Z table only has CDF values, right? So we will rewrite this in terms of CDF of Z. This is important because again the Z table will not give you a value probability Z is greater than some value. It will only have probabilities for Z less than equal to some value, right? So it's 1 minus probability Z is less than equal to minus A is 0.25. And then we can write this now as, if we just simplify this 1 minus 0.25, 0.7, now I can write this as 5 minus A because the Z table would have this probability, right? The Z table will give me the probability of Z being less than equal to minus A because minus A is greater than 0, right? Z table does have as CDF values for positive values of Z. So now minus A can be found as phi inverse 0.75. We can now read from Z table. This we can read from Z table. So this we can now read from Z table. First we'll see is 0.75 present inside the Z table. If it is, we'll just see the associated Z value. If it's not present, we'll see what two values does it lie between. Right. So it's not present. So we don't have 0.75 in the Z table. So we'll see what two values does it lie between, right? So it lies between, we can see 0.7486 and 0.7517. Now, if they both are equal, so the associated Z values are this. Let's just highlight these quickly. Right. No, oh, my bad. So the associated Z values are this, right? 0.6. 7 is associated with 0.7486 and 0.68 is associated with 0.7517. If they both are equidistant to 0.75, we'll take an average of these two Z values. If one is closer, then we'll take the one that is closer. In this case, 0.67 is closer to, in this case, 0.7486 is closer to 0.75 than 0.7517. So we're going to take the Z value associated with 0.7486, which is 0.67. So minus A is 0.67. So see, minus A is a positive number. So A is minus, sorry, so A is minus 0.67. So whenever you want to find the Z value given probability, so the way we go about um, doing this is that the first thing that whenever you do is you have to figure out whether A is a positive number or A is a negative number over here. If it's a positive number, it's very straightforward. If it's a negative value, then in that case you have to use symmetry property because because the Z table does not have CDF values for negative values of Z. So you have to first apply the symmetry property in that case. And once you write it, and once you have like this phi, once you have phi of a positive value of Z, then in that case, when you want to find the associated Z value from the Z table, then in that case, you see is that probability already present inside the Z table, then you just check its associated Z value. If it's not present inside the Z table, you see what two values does it line between. If it's equidistant from both of the values, if its difference from both of the values is the same, then you take an average of the associated Z values. If it's closer to one than the other, then in that case, you take the one which it is closer to its associated Z value. But the first step is always to figure out whether A is a positive value or a negative value. And for this, we keep in mind that on either side of 0, the area is going to be 0.5. So, and because if it's a negative value, then in that case, you do have to use symmetry property because the Z table will not give you the, because Z table does not have CD values and negative values. So Z, right? If I had tried to do it like this, we can't, right? Like if you had tried to written it as phi of A is 0.25, like we did part A, and then try to find A as phi inverse 0.25, you will see the probability over here starts from 0.5. There is no, you can't find 0.25 in this table because again, it only has CD value for positive values of Z. doesn't have negative values as z, so you won't be able to find 0.25 anywhere in the table to find associated z value. So you can't do part b like part a, because in part a this a was a positive value, so its cdf value is directly present inside the table. In this case a is a negative value, its cdf value is not present inside the table, so you need to use symmetry property.